Good afternoon, and thank you for joining us. My name is Ben Masick. I am the Worldwide Business Development Lead for Media Entertainment here at AWS, and I'll spend the next few minutes talking through the latest media and entertainment industry news from an AWS perspective. We've been seeing a lot of our media customers continuously and rapidly perfecting their media workloads by innovating on AWS, and we're seeing this across the entirety of the media lifecycle, from content creation and post-production all the way into the different forms of distribution. A lot of this, of course, enabled and connected through automation of media supply chains with asset management helping along the way. We're also seeing a lot of use of machine learning and analytics, and in many situations, this is actually helping enhance and optimize a lot of these different media workflows. In particular, we're seeing a lot of use of ML and analytics as far as helping with consumer engagement, with learning more about consumers, with providing better user experiences. During reInvent, we've been very fortunate to have several great pioneering media customers. We've got two of them actually that are going to join me later on stage here that actually have been innovating and building next generation media workloads in an AWS type environment. We heard from Turner that is doing some great work in terms of edit in cloud, all on AWS. We also have been hearing from Untitled Studios. They're actually one of the first to actually run their visual effects studios in an AWS infrastructure environment. Rock and Roll Hall of Fame also is moving a lot of their content archive and content library all on Amazon S3 storage. They're also leveraging machine learning tools as well as AI services such as recognition to extract a lot of the rich metadata. We're hearing from Fox. They are doing some fantastic work. They're actually building out their transformative 8K capable media platform on AWS. Fox will actually be using AWS Media Services to deliver its linear broadcast workflows. And I'm sorry, a couple more. We also have HBO that's doing some great work also in broadcast. They're actually now running some of their broadcast for channel playout on AWS. Eurosport is building innovative direct-to-consumer experiences, delivering live sports across devices and borders. And finally, Hotstar is actually doing some really cool work. They actually set the world record this year in terms of number of concurrent live streams for a sporting event being hosted in an OTT-type environment. With all these great media customers, with all of you in the room and many of your peers from around the world, we're continuously pushing the envelope in terms of hearing about new requirements, new requests, as far as how we can actually help advance a lot of these next-gen media workloads. And we're continuously looking for understanding what are some of the next solutions, next AWS services that will be of help. And as we prepare and move into 2020, some of the areas that we've been focusing on for quite some time, all based on a lot of requirements and asks from so many of you. First off, revolve around low latency where it matters most. And this is all about connecting a lot of the creatives, connecting a lot of on-prem type environments, and allowing for those media flows from on-prem to move into cloud, to move into our AWS regions, and then to allow that same content, once transformed and packaged and ready, to then move to all the various distribution points, including off to all of your mini consumers. We're also going to talk through a lot of enhancements in terms of new AWS services, whether it's for compute, for networking, for storage, AWS Elemental Media Services. And then finally, we'll talk through some advancements and new artificial intelligence and machine learning services that are helping make our media workflows smarter. AWS Local Zones is going to help extend AWS to more locations. Our first AWS Local Zone is going to be available in Los Angeles, connected to US West 2 region. Fox is actually going to be using this local zone, and we're very excited about what local zones will allow a lot of our media customers to do as far as helping, for instance, run remote workstations and visual effects types of activities, as well as broadcast production types of use cases. AWS Outposts is all about bringing the AWS infrastructure directly to your facilities, directly on premises. This can help in a variety of situations, such as bringing your on-set and on-venue infrastructure or having AWS services in your on-set and on-venue infrastructure. This could help with workflows such as maybe running remote location dailies and be able to run those dailies and process those dailies all utilizing AWS services through Outposts. Finally, we'll also talk about AWS wavelength zones, 5G connected outposts to local telcos. And really what this boils down to is the ability to leverage 5G connectivity for different field locations. This can help with live news feeds, for instance, or maybe with sports venues, and getting that content into your outpost and then into the cloud for preparation for distribution out to your consumers. A lot of these advancements in terms of connectivity, in terms of lowering latency, certainly are going to greatly benefit the broadcast operations of tomorrow. And we're already working with many leaders throughout the industry. We announced Fox, of course. We've been working with others like Discovery, like HBO, as far as their broadcast playout operations in cloud. And we're also going to be working more and more on live production for broadcast. So stay tuned. We're seeing a lot of excitement around the world from many broadcasters who are now preparing to move a lot of the broadcast operations into an AWS-type setting. We've also been working with the compute team to optimize a lot of the EC2 instances to help with media workflows. We announced on Tuesday AWS Graviton 2 processor. This is going to help provide up to 40% better price performance for some of your media-intensive workloads. We also announced latest generation of NVIDIA T4 GPUs. This will help also with remote graphic workstations, with video transcoding. And finally, one of my favorite here is AWS Compute Optimizer. This is leveraging machine learning to help identify and recommend the optimal Amazon EC2 instance types for some of your workload compute intensive types of operations, such as, in this case, rendering, transcoding, or maybe even video processing. Media workflows are becoming more and more a global affair. They're involving many different contributors from different parts of the world, creatives, partners, and whatnot. And from a networking perspective, we're connecting a lot of the dots with accelerated site-to-site VPN using AWS Global Accelerator. We're also seeing advancements with AWS Transit Gateway, cross-region peering, and multicast support. CloudFront now is up to 210 points of presence around the world across 73 cities and 37 countries. From a storage perspective, we're seeing quite a bit happening with Amazon S3 replication time control. AWS Data Sync and Amazon EFS are also now adding many more regions around the world. From an AWS media services perspective, also seeing a lot of new advancements and feature releases over the last several months. Media Connect now supports RIST, Reliable Internet Stream Transport. Media Live now supports MPTS, Multi-Program Transport Stream, for broadcast distribution with support for StatMux outputs. On the Media Convert side, several releases, Dolby Vision HDR support, Dolby Atmos. We've got accelerated transcoding at up to 25 times normal speeds, 8K support, IMF interoperable master format support. Also, with Media Package, we now allow for just-in-time packaging for video on demand. Media Store is now supporting chunked object transfer. This will allow for ultra-low latency for end-to-end OTT workflows. And finally, Media Tailor is now supporting ad insertion of live pre-roll advertising. We also have been rolling out several media solutions over the last 2 years, and in the last few months, we've actually made some updates to some of our existing solutions. These solutions can actually be found at aws.amazon.com/media/solutions. Check them out. We've got a lot of good stuff in there. Some of the solutions that we're highlighting because of recent releases are Edit in Cloud, Media to Cloud 2.0. This will help with ingest of content from your existing on-prem asset management solutions into an AWS-type setting, as well as Media Insights Engine. And this is going to help with your media analysis and insights for use cases such as search, discoverability, quality control, moderation, and monetization. And finally, I'd like to just make mention of some fantastic new services in terms of artificial intelligence and machine learning that, once again, are going to help a lot of our media workloads just become that much smarter. We've got Amazon Recognition custom labels, which will help, for instance, with detection of logos, icons, characters, products. Amazon Kendra, very excited about this. It's still in preview. But this eventually will help us with searching across rich media, leveraging artificial intelligence and machine learning with these searches. And then finally, Amazon Augmented AI. And this will help with workflows that involve human interaction with ML predictions and inferences. These are great for use cases such as content moderation, subtitling, and so on. And so I'm just extremely excited about what the future holds as far as next-gen media workloads running on AWS. If you have any questions or would like to find out more about any of these services, please reach out to your account managers. We'll make sure to bring in the right specialists to help you as you innovate with your future media workloads. Thank you. And next on stage, I'd like to present and introduce to you Steph Lone, who is the Senior Vice President of Engineering at CBS Sports Digital, and is going to give you a quick overview of some great work they're doing there.
Great. Thanks, Ben. So first I want to say thank you to Ben, and I also want to say thank you to AWS for allowing me to take the opportunity to talk a little bit about CBS Sports Digital and the types of things that we do with all the different AWS services available to us as a media company. And so, first of all, you might be wondering, what does CBS Sports Digital actually mean? And so we like to think about CBS Sports Digital as our key portfolio set of brands that starts from preps and takes you through to pros and offers you services for everything that you need in between. So I'm just going to highlight a key couple of brands that we have, but like Max Preps, which is the #1 high school sports site in the US. We have 24/7 Sports, which does our college sports and recruiting. We've got Sportsline, which is our gambling news and information service, and many others, and so you guys can always go to our sites and take a look at the different offerings that we have there. But today I'm talking a little bit about CBSSports.com, and I think first and foremost what CBSSports.com this year has been known for is our live streaming of a little event here in February called the Super Bowl. So every year, there's record-breaking audiences coming to the Super Bowl to watch the Super Bowl. And so we knew that we needed to create a new playbook as we went into this year's Super Bowl. But as a traditional media company, we take a very risk-averse and a very redundant approach to how we do events like this at the scale that we need to do them in. So I'm going to take you quickly to a high-level architecture. I'm just going to walk you through a little bit about how we deliver an experience like this to our fans and consumers. So I'm going to start at the left-hand side of this diagram. So one of the things I want to point out here, and a key to our approach, was not only do we want the Super Bowl stream and the game itself to be good for the consumers, but there's the all-important Super Bowl ads as well. And we wanted to make sure that the consumers and our advertisers got to have those ads with the same quality, the same stability and reliability as they did for the gameplay. So that informed a lot of how this was built. So starting with origination on the very left-hand side, we get multiple feeds from the stadium. They come in over fiber and satellite into our broadcasting center in New York. Now, I'm going to only focus on the New York workflows here, but we also had a fully redundant version of this in our Los Angeles facility as well. So from the broadcasting center, those feeds were routed into our CBS Sports co-ward rooms. And then from there, we worked with a third party, one of our third parties, to integrate with our systems to add custom enhanced SCUDdy markers so that we could burn the ads directly into the linear stream. And once we did that, we inserted those custom SCUDdy markers, and our team wrote some custom software to be able to pull those and convert them from SCUDdy to ID3 markers and insert those ad tracking tags back into the stream. So with so many streams going into so many encoders, we actually worked very closely with the Elemental Live team, who actually created the output locking feature for us. So if we lost any one encoder during the game, we could fail over seamlessly to another encoder. From there, we actually took the stream and pushed it dual redundancy here, direct connect out to Media Store East and West. And so that kind of takes you up to the first half of this diagram. So I'm going to start on the other side. So with the size and scale of the Super Bowl, we knew that one CDN vendor would not be enough to handle all the capacity needs that we were going to have that day. And so we decided to work on multi-CDN decisioning. So using Sidexis, we created an open mix application that utilized criteria both for quality of experience as well as our capacity reservations so that each consumer could get the best quality of service and the best experience to their individual region of the country or wherever they were to watch the game. Okay. And I think the results speak for themselves. We had about 7.5 million unique devices during the Super Bowl. And while we're known for big tentpole events like the Super Bowl, we also stream plenty of events throughout the year, both large and small. So an example here is about 18 months ago, our business development team came to us with a request to start streaming about 25 times the amount of games and events that we did prior. So I thought that was fantastic. They said, yeah, so you've got 5 months till the first game. And I said, okay. And then I asked about a budget, and they said, well, actually, you really don't have more real budget with more operating or CapEx costs. So the team got together and said, okay, we clearly need to move to the cloud. So we knew that we needed the ability to spin up and tear down infrastructure for each and every event that was going to happen without kind of dedicating ourselves into some hardware costs or long-term costs. So outside of the business challenges of having to do this, we actually ran into a couple technical challenges as well with utilizing Media Live. So as you can imagine, with sporting events, hundreds of events actually spin up at the same time. And Media Live actually has a hard throughput limit of 5 transactions per second. And so with all those events, we needed a way to actually handle the influx of those events. We also needed single domain access so that our partners would not have to reconfigure all of their encoders at the edge. And we also, about 30% of our events are audio-only events. And Media Live actually doesn't handle audio-only events without a video stream. So we solved a few of our challenges here with 2 main solutions. First, actually, we added an Nginx proxy running Nginx RTMP, which we added custom token authentication, and then we converted our RTMP streams to RTP using FFmpeg. And the last thing we did here is integrate that proxy with DynamoDB, which then allowed us to introduce step functions. And this allowed us to provide that statefulness that we really needed in that channel creation process. Each of these channels takes about 1 or 2 minutes to spin up. So you can imagine in that influx, we would be overwhelming or oversaturating Media Live with all these different requests. So we store our statuses now in DynamoDB, and we can go through the process. But I think the real key here for us is staggering our scheduler when events start. And so we actually put 5-second staggers between each of these starts, as well as taking the initial start time back about an hour to make sure that all the events could have their channels start up by the time the actual event would start. So video isn't the only place, though, that CBS Sports Digital excels. As you can imagine, sports is a highly dynamic and data-driven industry. Right? Data is the foundation of our core experiences for everything from scoring to fantasy to gambling. So while our architecture was well-suited for media delivery of the past, we recognized that we needed to reinvent ourselves and reinvent ourselves with data. So our consumers are expecting higher data quality and better speed, and we knew that we were going to be getting multiple vendors for every single data point that we had in our databases. We also are going to be collecting localized lines for odds, and we wanted to create near real-time simulations on that data and create new data points of our own. So this led us to the creation of what we call our CBS Sports Digital Stat Lab. In talking to AWS, they offered us a solution on how to get there, which was the AWS Data Lab. So we took 14 of our finest people, some of them sitting here in the front of the room, And we immersed ourselves for 4 solid days in New York with the top talent of AWS listening to our data challenges and our data needs. So while we were there, we developed and iterated in real time a functional POC that allowed us, and they allowed us this access to their top product and talent, so every time we got stuck, we could move through that very quickly and get to the next iteration of a pipeline. So we developed different pipelines for batch as well as live, and we built a data lake that we could do further exploration of the data on top of. So here's an example of inspiration that's kind of fueled from the creation of our data lakes. Our data science team and a third party helped create some simulations on top of our real-time data, and we are projecting the score after each and every play for football and incorporating that into our products. But we don't just use AWS's AI/ML for simulations. We also use it for automation purposes, and this helps us in the areas of closed captioning, automating our content availability, and also empowering discovery internally. So internally dubbed Project Clicker was created, and our data science team takes in our CBS Sports HQ 24/7 digital stream, processes this stream, and cuts it up into visualytics and what we call audiolytics, and uses a combination of services between recognition, transcribe, and comprehend to extract the metadata and the information that we need from our 24/7 channel into not only our data lake, but multiple data stores across our ecosystem within CBS Sports Digital. So I'm just going to show you a couple examples here of how we utilize all of this automation. And so this is actually a web page on cbssports.com and an article on cbssports.com. If you go there and you take a look at the videos and you click the closed captioning button, all of this is 100% automated. This helps us not only with accessibility, but compliance. This next is an automation benefit that we got with the metadata that was created. So we are actually able to automate all of the sports highlight clips and put them on different areas of our site. So this was a manual process to date, and we removed that manual process, and via the automation, we're able to deliver these sports highlight clips not only to our scoreboards, but across the site in the right places at a faster pace than we did in the past. And then lastly, and then lastly, this is about empowering discovery. And so we use all of that metadata and fuel in our proprietary CMS system the information that we need so that when our editors are creating articles in our CMS, they are able to more quickly pull up and get related content, videos and images to embed, and other related articles or recommendations. So with that, I'm going to hand this back over to Ben.
Thank you, Steph. Just incredible to see how far CBS Sports Digital has come in so little time. But yeah, just very, very impressive. Next on stage, it's with my great pleasure that we are going to have Mario Chauvin. He is head of engineering with The Guardian News and Media and also has some fantastic use cases. You're in for a treat.
Thank you. Hi. Thank you, Ben. Thank you, Amazon, to have this opportunity to speak in front of you. Today, I'm going to introduce quickly The Guardian, and then I will tell you how we have been able to scale moderation of our content thanks to machine learning and AI technology. I will as well present 2 other use cases on how we use them. The Guardian is a British daily newspaper which was founded about 200 years ago in 1821. The Guardian is available online with 3 editions, an American edition, a UK edition, and an Australia one. Unlike many news organizations, The Guardian is independent. It is owned by the Scott Trust, which mission is to secure the editorial and financial independence of The Guardian and to safeguard the journalistic freedom and liberal value free from political or commercial interference. If you don't know us, The Guardian has broke news in the past with the mass surveillance from the US administration of citizens with the SPRITZ program, and more recently, we have led the Panama Papers investigation. The Guardian Digital is a department which is responsible for developing most of the news experience, world-class editorial tools, and add revenue to the bottom line. The Guardian Digital department is composed of 15 software development teams, which are improving and running our website, our apps, as well as our editorial tools, our analytics platforms, and ensuring our revenue system and integration works well. The Guardian Digital activities now made up about 55% of the Guardian revenues, and we are continuously growing our audience. We are now seeing 40 million daily page view, about 10 million unique, and that represents about 1.3 billion page view monthly. About 4 years ago, The Guardian started this digital transformation by moving to the cloud. We were one of the first companies that decided to move to the cloud natively, which means choosing a single cloud provider and moving all of our applications at the same time. In 9 months, we moved about 17 applications, and it has been a fantastic success story. We are now deploying our application in total 40,000 times on prod, and we have been able, while growing our audience by more than 30% in the last 3 years, to reduce our operational cost by more than 25%. That will not have been possible without AWS and the cloud services. However, what growth means new challenges, and one of them is the moderation challenge. We have a lot of people that comment on our article. We got about 80 million comments. Even if only a small part or a small percent of our audience are commenting on The Guardian, people that comment, people that read comment, are our most highly engaged users. So we need to serve them well. They come more frequently to the Guardian website, they read more articles, and unfortunately, 2% of posted comments are abusive. So how do we solve that problem? 3 strategies. The first one is by educating and guiding our readers, sharing with them our community standard, what we expect from them. Second one is by preventing them to comment. Simply, on some article, we know the subject is too sensitive, so we simply close the discussion. We are not allowing comment. We know it's impossible to moderate those. And the third technique, or third strategy, is to use moderation. Either pre-moderation, when we know there is some legal sensitive or author which are quite risky, or post-moderation, which is either threads reported by users or risky topics. When we say moderation, it means we need some moderation tools and moderators. And this is the issue, because when you content scale, your moderation scheme can't scale. So the project we had and the challenge we had were how to scale moderation. In practice, it means how can we reduce the workload of our moderator teams, which means is there a way for us to moderate content without human intervention or less human intervention, and keeping that cost efficiency. Fortunately, the things we do when we started the project is look at research. Antisocial behaviors is not something new. Antisocial behaviors in online discussion communities is not something new. Online discussion communities have existed since the internet existed. And what we found in those research documents is that users and bad users behave differently. That gave us a fantastic insight that we will be able to use machine learnings to solve that problem. Because if bad users, if bad commands have different characteristics, we can use those characteristics to try to decide or classify if a command is abusive or not. So, what does it mean to use machine learning to detect bad commands? It means trying to evaluate or trying to transform a human task to a math problem and solve it with a machine. In practice, we can say that classifying if a command is abusive or not is to find a function that either returns 0 or 1 and which take multiple parameters, each parameter being one of the characteristics we are going to evaluate. For instance, we can use two characteristics, the number of bad words in the command and the abusive commands in the past by your users. We can visualize this quite easily when we have only two parameters. If on the y-axis we take the number of bad words, and on the x-axis we take the number of abusive commands by a user, we can plot each command on this graph, and then the scoring function becomes what is the line we draw, where above the line there is commands that are not abusive, and on top of the line there is commands that are abusive. It's quite easy. Of course, the more parameters you add, the more complex this visualization becomes. So, when you start an ML project, you are going to do it in 5 steps. Here are the 5 steps we have used. The first step is to choose an ensemble method. The ensemble method is the machine learning techniques you are going to use to produce the models, how your models are going to be selected and evaluated. In our case, for a classification problem, we choose a random forest classifier. There are other techniques that just depending on your outcome and your context that you should make that choice. Secondly, is to choose the features, the characteristics you are going to use when you do your classification problems. On our case, we started with 2. Bad words, and number of bad words in a comment, and number of capital in the comment. One very important thing is to choose uncorrelated features. If you are not choosing uncorrelated features, you are going to end with a model with bias. And an example of correlated feature, an intuitive one, will be the number of words and number of cars in a comment. The third step is to train a model with a large enough representative data set. Fortunately for us, we have a huge archive of comments and moderation done by our moderation team. So we trained our model around 500,000 comments. And then you need to evaluate. You evaluate the model performance. For that, you are going to use several metrics, such as accuracy, recall, precision. This is fundamental. All those 4 steps, you are going to iterate on them. This is the 5th step, is to do the iteration. And you don't have to do many of them, because as soon as you get something that is good enough compared to your performance metrics, you are fine. In our case, it took us only 3 iterations before we found a model that was matching our expectation. Here is the architecture diagram and technology we used. So we have our comments, which are in the RDS database, and we have been using Amazon EMR with Spark to train the model. So we retrieve the comment, we train our model. When our model is ready, we save it to Amazon S3. Then we build a very simple abusive command API on top of EC2. So I'll just receive a request from a moderation tool. We'll fetch the comment, fetch the model, and check if the comment is abusive or not by using the model. Very simple architecture diagram, very simple set of technologies. Results have been fantastic. We have been able to reduce the moderator workloads by more than 20%. And we've done that with a very few number of false negatives, which means we don't miss a lot of abusive comments. More interesting, or area under curve, which is a metric used, is classified as excellent. What does that mean? It means that our machine learning models we have built has better results in terms of detecting if a comment is abusive than comments reported by users, which was not a given when we started the project. Using machine learning for detecting if comments are abusive is not the only area where we are using machine learning. Another area is segmentation. If you go currently to The Guardian, you will see that the experience you have, the experience of consuming the news, is identical to all other users. This is not great. We could personalize more the user experience. To do that, we need to segment our data. We need to understand better where our readers fit. And with better audience understanding, we will be able to provide this personalized experience. Here is a diagram of our data platform architecture. You can see that we collect a lot of information. The page views, the sign-in users, how people are subscribing, or marketing campaign, or advertising analytics. We transform a bit that data, we clean it, and then we put it on S3, and we instantiate Amazon Athena to provide the data lake. This is great, and our data and insight team can use that data to try to figure out data and insight. However, we can use Amazon SageMaker to try to provide us what are the segments of our audience and how we should treat them to drive more results. So on top of that data lake, we are using Amazon SageMaker to provide the segmentation API that allows us to tell this user is in this segment. We need to show him more advertising, or to the contrary, this user is not reacting well to advertising. We should probably not showing him this. The final use case I want to show you today is regarding journalism investigation. Unfortunately and sadly, Instagram has been used to promote self-harm. In the beginning of this year, following a tragic suicide case, Instagram decided to ban self-harm images. This is great. However, as a media organization, we want to make sure they are doing this effectively. So we built a prototype to check how effective Instagram moderation was. And to do that, we just used some very simple but advanced Amazon services. So we use Amazon Lambda to collect Instagram self-harm tags posts. We used Amazon Recognition to recognize the images that were posted by the users. And we use Amazon S3 to store that information. And thanks to Amazon Athena, we are able to query that kind of database we are building. More specifically, with Amazon Recognition, if you give him give Amazon Recognition an images, it will return JSON metadata that you can store. For this example, it will be a cat, an animal, a pet, with a threshold of a level of confidence. We can store all of this in S3, and then with Amazon Athena, we can create a schema, and using that information, we can build queries that are going to tell us if there is self-harm images. So we build a simple scoring function which check if there is a hand, if there is a wrist, and if it's not a tattoo on selfie, and you just allocate a threshold number. Using that, we have been able to check how Instagram moderation was effective or not. It took us less than a week to build, and it was absolutely fantastically well received by our editorial team. Thank you. That concludes my presentation. I hope you find it inspiring.
Huge thank you again to Steph and Mario for some great presentations. The three of us will be around if you have any questions related to any of what we covered. So thank you again for your attendance, and I wish you a very fun time at Replay this evening.